I just want to give you a very quick overview of what is safeguards. Why are we doing it? What is the relation with small modular reactors? And what is safeguards by design and how do we use that? So very quickly, IAEA safeguards, the whole point and the whole role of the IAEA is to verify that states are honoring their safeguards obligation and their international treaty with the Treaty of non-proliferation of nuclear weapons. This is my personal shame working for the IAEA, and I can't even pronounce non-proliferation very well. So sorry about that. I have never been able to, in these 23 years I've been working at the agency, I cannot say that consistently correctly. And so how do we do that? We do that once a state concludes their the NPT agreement with member states. They have an obligation to conclude a safeguards agreement with the IAEA to verify that they're meeting their obligations under the NPT. And this would include the small modular reactors, regardless of whether they're pilot plants, operating power reactors, or whatever purpose they may be, whatever the size may be, it's always going to be the case. And so this will be very important to vendors who are going to be deploying these reactors in, for instance, non-nuclear weapon states. And so just before I go on with that slide, I just want to mention that we have two types of agreements that I'm going to be referring to here. Actually, there are several other types, but mainly we're going to be talking about the CSA, which is a comprehensive safeguards agreement, and that's under the INFCIRC 153. There's also a subset of the 153 agreement, which is considered a voluntary offer agreement. And this is a type of agreement that is concluded with weapon states. And typically the weapon states don't have full-scale safeguards applied to them. So especially this is going to be important discussion for those vendors that are coming from nuclear weapon states, since often they don't have a whole lot of experience and knowledge about what safeguards is for the plants that they will be designing. And if they export those plants to the non-nuclear weapon states, certainly their customers are going to be interested in whether they're going to be able to meet their safeguards agreements. So I just want to point out too that safeguards and proliferation resistance are not the same thing. Proliferation resistance is a design that makes it more difficult for a proliferator to divert nuclear material into misuse facility. And safeguards is the actual implementation of the verification activities to ensure that the safeguards obligations are being met and the legal agreements are being met. And in no way does a proliferation resistant design somehow bypass that requirement. So safeguards challenges for the SMRs. These are the types of things that we're going to be looking at when new designs come out on the market. So we're going to be interested, the IAEA, in advanced fuel cycles. This will involve new types of fuels, fuels that we've never had experience in verifying before. So we're interested in seeing how those develop and what kinds of strategies can we apply to verify them adequately. Advanced reactor designs that we also have very little experience with or no experience with. Longer operational cycles. Not all of these are going to be operating on an annual basis. Many of them are going to have significantly longer operational cycles, which is going to change the way we approach safeguards. New supply agreements. This is particularly interesting for us for instance, the floating nuclear power plants, because these will be delivered as sealed cores in some cases, and we won't necessarily be able to access the fuel to even verify it within the core. And so we have to find new strategies there. Spent fuel management, we're going to be interested in how the fuel is going to be stored for these new types of designs. What kind of containers are they going to use for them, and how can we apply safeguards to those containers, those items, and a smaller footprint. Of course, this is going to affect possibly how we access those new design types. Additional ones, diverse operational rules. So there's going to be many different purposes for these reactors. They're going to vary from district heating, desalination, and even some that are going to be deployed in remote regions. For example, think of, like, say, a floating barge that's going to be on one of the oil rigs. How are we going to get out there? How are we going to be able to apply safeguards? Multiple module plants. There's going to be some variation in the nuclear fuel flows within the sites if there's going to be multiple plants. Sheer number of designs, and I don't need to say anything more about that. That's just a fact that we have to figure out how we're going to be able to maintain efficient and effective safeguards with the number of plants that actually come out on the market. The lack of safeguards awareness is a big challenge for us because a lot of designers don't have a lot of familiarity with IAEA safeguards. And this is a bit of a risk for us because this is an absolute necessity if those reactors are deployed in states with a comprehensive safeguards agreement. So we must be prepared. Safeguards needs for SMRs. Okay, so what we're talking about when we say we need to apply safeguards. An inspector, the IAEA in general is going to be considering many different factors on when a new reactor comes out on the market, when it's going to be constructed, when it's going to be built and operational. The types of considerations that we would discuss are, for instance, unattended monitoring systems and remote data transmission. How are we going to build these into the reactor? And this is regardless of whether we've already had the discussions during the design phase. Digital connectivity. If we're going to do remote monitoring, how are we going to collect that data remotely? Are we going to have the reliable network system? Are we going to have sufficient bandwidth? Safeguard seals, where are we going to apply those seals? Do we have sealing points that we could even apply the seals? Design verification, how are we going to perform that design verification? New reactor designs may not allow access to certain areas because of high radiation, for example. We have to develop new safeguards approach for the new designs. And this has to be done on a state-by-state basis. And this brings us to the state level issues because this could significantly change the nuclear fuel cycle in a particular state. This is going to be very important with the small quantity states that we have currently that don't have a nuclear fuel cycle. Suddenly they will, if they adopt one of these reactors, they're going to have that nuclear fuel cycle and they may not be familiar with safeguards application. And then of course, we need training for these particular states that don't have the familiarity in applying safeguards. So we've already established internally several groups of people to reach out to those member states that are planning on adopting the small modular. Okay, what is safeguards by design? Safeguards by design usually ideally takes place during the design phase. And that would mean early discussions with the vendors, with the designers, at the same time that there's already discussions underway for safety and security, for example. Safeguards, in any case, is going to start at the point where construction and commissioning takes place. So when a state announces that they're going to construct an SMR, then they have to have already given us advance information on the design, and that's when safeguards will kick in. When they receive the first fuel, or in the case of sealed cores, when they receive the core, then at that point, we will actually start the verification activities. Before that, we would be doing design information verification. This is not the ideal point to apply safeguards, and I'll show you why in the next slide. But ideally, what we want to do is have those early discussions with designers so that we can find solutions in advance before we get to the construction phase. And the reason for this is because I just want to go here, is that by having these early discussions with the designers, with the vendors, we can reduce that operator burden and maybe make the safeguards more efficient and more effective at the same time. We avoid retrofitting of safeguards equipment, for example. We need to make sure that we have sufficient locations and sufficient power supplies for our equipment if we want to install surveillance systems. If we want to install unattended monitoring systems, we have to have places for the cabinets. There have to be space for that. If we want to apply seals in a particular area, we need to have a sealing points that meet our requirements. These all have to be negotiated during that design phase, and not all of them will be possible. If it is not done during the design phase, if it waits till the construction phase, then of course we may have to request some sort of retrofitting, which will increase costs. By doing this in the early stages, of course, we have a chance to discuss possible joint use equipment solutions. We also improve our possibility and flexibility to be able to adapt to new technologies, because the IAEA is constantly looking for new technologies in trying to improve the equipment and the verification activities that we can already discuss in an early stage what type of data that the agency needs to be able to confirm and to verify the activities in the facility. And we reduce risk overall for the IAEA, for the designers, and for the member state that receives the reactor. So challenges in implementing safeguards by design. We have a lack of direct communication with vendors. It's unfortunate, but we can't reach out to the vendors directly to be discussing with them. We don't do cold calls and try to get business at the IAEA. That isn't our job. But if a designer reaches out to us, then we're happy to help. We're happy to answer questions and to give them some guidance on how they could go forward. We're always available for that, but normally if we do a full-scale safeguards by design, then what we would be doing is requesting the designer or the vendor to go through either the member state support program or through the mission for the member state in which they're operating, or going to their regional or state authority to ask for advice on how they can connect with the agency to perform the safeguards by design process. We need, and we sometimes lack a uniform understanding. Not all parties, not all stakeholders have an equal understanding of what is required for safeguards. And we like to try to close that gap. And so we're always available trying to do that. Safeguards is not seen as a design driving force. Often the focus is on safety and security, and safeguards is taking a back place in that process. Inconsistent licensing practices and proprietary and commercial concerns. I know that vendors would be very concerned about the security of the information that they provide the agency in order to be able to review the design and to design some sort of a safeguard strategy for the design. And so we have to deal with that, and we want to be able to assure those vendors that their information is kept secure. So I want to give a quick example of what does it mean to undergo safeguards by design with a member state or with a vendor. We would initially be contacted, whether it be through a member state support program directing us to a particular vendor, or or the vendor coming to us directly and us forming some sort of a non-traditional partnership where we work with the vendor on trying to find a safeguard strategy. Following that, we would have a series of meetings and we would discuss and negotiate particular safeguards measures that can be put into place. This is a completely voluntary process, and we would not enforce any particular measure or any particular modification of a design. The vendor has to agree to that. That's not our job, to force vendors to change their designs. But in many cases, modifications that we might negotiate would be very minor, and they would save the vendor a lot of headache, and they would also save the member state that would purchase the reactor a lot of headache. So it's a good idea to do this. And then finally, we would produce some sort of a safeguard strategy report. This would be used only internally within the agency. Agency would then share this with the particular safeguards division that would be responsible for a particular member state that was receiving the reactor. And they would design a safeguards approach based on the nuclear fuel cycle for that. So IAEA safeguards by design for SMR activities. We have several activities that are going on internally within the agency with the member state support program tasks. We have at the moment 7 states that are working with us on particular designs. We have a total of 10 reactor designs. And for the MSR designs, we are currently working with Multex and Terrestrial Energy, which I know are here somewhere. I think there was some representatives here. And we're undergoing the full safeguards by design task with them. We also have several other member states with representing different types of designs, including a pebble bed reactor design and some micro reactors, some integral PWRs and BWR. And we have a floating reactor design that we're currently looking at with a member state. And our goal is to raise awareness on safeguards by design and the safeguards requirements and obligations for member states, to evaluate design for potential impacts to safeguards, and to investigate potential safeguards implementation strategies together in cooperation with the vendor. Internally, we also have an agency-wide SMR platform. This is where we come together with the 3S. This is our safeguards, safety and security, and we collaborate to try to learn from each other and find ways that we could better provide services to the member states for the new SMRs. We also have a safeguards by design working group where the different departments come together and share best practices. we have some external engagements where we come to venues like this, for example, and try to spread the word and help vendors to understand what the obligations will be and how we might be able to help them. How can stakeholders help with safeguards by design and with rolling out these new reactor designs? They could raise awareness to their licensee for the regulators. They could let them know what is IAEA safeguards, who to contact. They could encourage a three-way discussion with the state authorities, the IAEA safeguards and designers, and the NGO and R&D communities can raise awareness on safeguards for the researchers that are working on these small modular reactor designs. And the same with developers. I think we've already gone through that, to engage with us with safeguards by design. And even if they're not undergoing safeguards by design, they should never be afraid to contact us directly just to ask for advice and guidance on how safeguards, they could make their designs more compatible with safeguards. So anyway, these last two slides, I'm just sharing some QR codes where you can go online and you can get additional information if you're interested. There's some very nice online training courses at the IAEA website, and also some guidance books on safeguards by design that you can download and review if you want to learn more about what is IAEA safeguards and what would be safeguards by design. And I think these slides are going to be shared, so you'll have those QR codes available. So anyway, so thank you very much.